Okay, welcome to this week's Megaport Live Tech Drop-In. The topic for this week is routing options on MCR. So basically what we'll do is run through some general info about MCR and what it does and where it fits in and how the architectures typically build out, and then more specifically about the routing options and how you can manage routes and things like that on MCR. So, as usual, we'll do a little bit of an overview first of Megaport itself, Network as a Service, and we'll jump into the MCR piece. We'll run through some use cases, some current common architectures that we see, and then the route filtering specifics. And there's some deployment guidance stuff as well at the end, just some suggestions as far as what typically works well, what we see often, and what customers do, what tends to work out best. So Megaport in general, Megaport's a network as a service provider, which basically means we run a very large global private network, on top of which we provide on-demand services to customers. So it's private connectivity, similar types of services that you might have previously gotten from some of the traditional carriers or telcos or things like that. But the big difference is that the actual way you interact with those services is very much aligned with the cloud provider model. So you get a self-service portal, you can log in, and then you can create whatever connectivity you need, wherever you need it, whenever you need it. You can add, move, change, and sort of self-service manage the whole thing, and everything's available on demand. So for the most part, customers connect to us from a data center. We do have some other models available to do things like SD-WAN deployments and cover edge sites, branch sites, and things like that. But the most straightforward solution is basically a customer's in a data center, they connect to Megaport, and then they can spin up on-demand private connectivity to whatever it is they happen to want to connect to. So most obviously, that's the big cloud providers. So we have private connectivity into all of the hyperscalers. And this is dedicated physical private connectivity. This is not VPNs over the internet. This is kind of physical cables and stuff that we have plugged into all of these places. Connectivity between data centers is another big one. So customers might use this to connect from one data center to another, especially if they're across multiple different data center operators, because we work across quite a lot of different data center providers. You can see some numbers over there on the right hand side that this slide's a little old, so I've added some updates in there until I can get the slide itself updated. So we're available in over 1,000 data centers around the world. We have connectivity to cloud providers across 300 plus on-ramps to a whole huge list of different cloud providers and other types of service providers. And you get access to all of this in a very cloud-like way. So you get access to the portal, you can create services whenever you want, spin things up on demand, add, move, change, and manage it in the way that you'd be used to using a cloud provider. So this gives you a bit of an idea of what the network looks like, where these 1,000 odd data centers actually are located. So we have a pretty extensive network globally. I think 28 countries is the current count, but it does increase pretty often. This basically gives you a pretty good view. So quite a bit around ANZ, up into Asia, quite a lot around EMEA, around Europe, and then North America. And then we've also now started to get some decent presence in South America, and recently also added India as well. So a pretty substantial global presence. So we can usually cover pretty near any area you might need to connect into. So to give you a bit of an overview of MCR itself, essentially it's an on-demand routing platform that you can spin up on Megaport's network. So we have that big global private network, and then within that network, you can spin up essentially routing instances to then do layer 3 things, right? So the connectivity itself, as you know, if you've used Megaport, you'd be familiar, is in the form of point-to-point layer 2 links, so VXCs, or virtual cross connects. And MCR lets you do layer 3 routing inside of Megaport's network as opposed to just point-to-point layer 2. So essentially, you spin up an MCR, you choose the location that you want it to sort of exist, and then you attach those VXCs to it, and the MCR functions as a router between those VXCs. MCR is available in speeds up to 100 gig per second. So most use cases we can cover pretty well. It's on demand. There's no additional licensing. There's no kind of separate management layer. It's very much an as a service managed product within the Megaport portal. So you jump in the portal, you create an MCR, all the config is done inside the Megaport portal. Or if you want to automate that via our API or via Terraform, there's no separate interface, there's no license required, there's no CLI or anything like that. It's very, very easy, very, very automated, very, very quick to deploy as well. Feature-wise, it basically supports static routing, it supports BGP, it supports some other bits and pieces to sort of facilitate that. Most of the time customers use BGP, definitely would recommend using BGP. It does support static routes, sometimes that's required. All the cloud providers do use BGP, so that definitely tends to be the most common approach. And then within that, essentially, we support BFD for faster failover. We support a couple of different ways to do route filtering. We support AS-Prepend and MED for prioritization. We support SourceNet and ACLs, layer 3 and 4 stateless ACLs, and also IPsec. So it is very simple, sort of by nature of the product, trying to be as fast and easy to deploy and hands-off as possible. It doesn't support every single feature, but it does have a pretty decent list, and it does cover most use cases for most customers. And then it's really, really easy. It's very hands-off, very, very automated. So this is the most obvious, most common use case for MCR, Megaport Cloud Router. As the name implies, oftentimes customers are using it to route between two different cloud providers. So there might be an Azure, there might be an AWS, or Oracle, or Google Cloud, or any other, and they want to establish some reliable private connectivity between the two. Maybe they're trying to reduce costs compared to internet egress. Maybe they're trying to have more stable, reliable connectivity than internet VPNs. Maybe they need more bandwidth, something like that. For whatever reason, customers want to establish private connectivity between two different cloud environments. So essentially, MCR gets spun up in the middle, and then a VXC is created from MCR to one cloud, and another VXC from the MCR to the other cloud, and MCR functions as the router in between the two, with a BGP session to each cloud. So this is really, really straightforward. For the most part, this all just happens out of the box. You don't really need to look at or think about the settings or options too much. For the most part, this type of deployment, super easy, super straightforward, very automated. The default settings will probably be fine. As you can imagine, though, a lot of the time in these sort of situations, customers do want highly available connectivity. So they want to have multiple paths that exist between the cloud providers that are split across multiple data centers for geographic redundancy, separate routing instances, all those other bits and pieces. They want to have two connections into each cloud, so two BGP sessions on the cloud side to have fully diverse paths all the way through. So this is basically what that would look like. Slightly more complex, but still really this with all the default settings on all the ends, usually this works, this works fine. It pretty much behaves the way you'd expect. The MCR will just re-advertise the routes that it receives to the other cloud. So it's pretty straightforward. What can also happen though is that there can be other things involved. So there might not just be two clouds, there might be 3 or 4 or however many. There might also be other things. There might be some data centers involved that you need to include in this network. There might be some connections even out to branch locations. There might be some VPNs. There might be all kinds of other stuff. So that's all fine. You can handle that. It's all just standard IP routing and BGP, so it's not super complicated, but you're starting to get to a point where you might need to factor in some things about how these routes actually get advertised. So what routes get sent to where. You might need to filter some routes. You might need some to be a different priority to others and that kind of thing. You can sort of see how as you move through this process, as you add more to the network, you start to need a little bit more control. But this is a pretty common architecture as well. A pair of MCRs within a city, within a metro, between some number of cloud providers and data centers, potentially the internet as well, potentially some VPNs as well. What we also see is a lot of customers have resources that are across more than one location. So they might have some cloud regions. Maybe you've got some in Sydney, maybe you've got some other cloud regions in London or something, maybe you've got some others in New York, or maybe you've got some stuff in Singapore, or maybe it'll be New Zealand, something like that. You've got different resources in different locations. And so as well as being able to provide that private connectivity between all your resources within a metro, within the city, you also need to be able to establish a private global backhaul, right? Private global WAN. So we can facilitate that as well. Basically, it's the same sort of process. You just create VXCs from the MCRs, between the MCRs, then they can talk to each other, they can route to each other, and you just use standard BGP to basically facilitate that global WAN with paths wherever you need. The VXCs themselves, you can scale up and down as you need. You can size these really granularly to be able to sort of right size and cost optimize the network. And then you can establish paths basically wherever you need and not wherever you don't. And being that it's all on demand, it's all self-service, you can modify this whenever you need as well. So it's very easy to keep scaling this as you grow, or even scale it up or down, or move it around as you happen to change requirements. Most customers use the portal. It's very easy, very simple to use. We'll have a look at that in a moment. It is possible to do all of this via Terraform as well. So you can automate this whole process via an infrastructure as code pipeline. And that includes things like configuring the IPs and the BGP details and managing some of these routing settings that we'll talk about in a moment. So the first two things really are how you can control which routes get advertised where and what priority different routes are. So for filtering, MCR supports filtering the routes that are advertised based on the peer. So that's basically saying routes from these peers can be advertised to these peers, but not these peers. So it's quite a high level, quite a broad control. So you're sort of saying essentially don't advertise routes from this peer to this peer, or do from this peer to this peer. To be more granular than that, MCR also supports prefix lists. So you can create prefix lists in the portal and specify essentially lists of subnets, lists of prefixes, and then ranges for how large you want that prefix list to be. And then either match or don't match those prefix lists, and then use that to choose what gets advertised where. So that gives you a little more granularity. As far as prioritization, you can do AS path prepend, which really tends to be the most common, or you can use MED. So they're both just standard BGP features. They're not unique to MCR, but MCR supports both of those. Probably just a sort of note from the field, AS prepend tends to be more common because it's a little more universal and it's transitive. So with AS prepend, pretty much everything everywhere will support it, usually the way that you expect it to. And that prioritization will be passed through all of the hops. So if you advertise, if you do AS prepend on a route to down preference that route to make it less prioritized, that priority will be propagated across all of the other hops, all the other routers it happens to bounce through. Whereas MED, it really only works that one hop. You're just controlling traffic between two immediately connected networks. But both are available. And the cloud providers, they do support both, depending on your requirement. So some other general guidance stuff. Fundamentally, MCR is a router that you can do what you want with. So all of this stuff is really guidance as opposed to rules or requirements. We have lots of different customers with lots of different requirements, and they use MCR in a lot of different ways. So essentially, this is what we see. This is what we see commonly, and some things that we sort of see work well, but you don't necessarily have to follow any of these. So diversity zones is the obvious one. We, for same as all the other products, recommend you deploy MCRs into diversity zones. So if you deploy within a metro, say Sydney, you'd put one in the red zone in one data center, one in the blue zone in a different data center. Typically one ASN per metro. So if you're deploying out that architecture where you've got multiple metros, or even if it's just one, typically would recommend customers use the same ASN for both MCRs within a metro, and then a different ASN for the different metros, the different cities. That tends to result in the type of routing that customers expect. It's up to you. You can change that. You can choose whatever architecture you'd like, but that tends to result in the type of behavior that most customers are looking for. Probably also another thing that comes up a bit is to consider the cloud provider limits. So some cloud providers limit the number of routes that you can advertise on their private connectivity services. As an example, the limit for AWS is 100 routes. MCR does a lot more than that. So sometimes just be aware that when you get to those points where you advertise to a cloud provider, that you might need to do some filtering or summarization. Something that maybe is not immediately obvious, the BGP IP for the MCR is the same as the interface IP. So for each interface you create, each VXC, there'll be an IP on the MCR, an IP on the other end of that interface. And that is also the BGP IP. So there's no additional IPs, there's no loopbacks or anything like that. You can use public IPs if you want. You can use private IPs. If you prefer routable private IPs, you can use link local, or you can use IPv6. All of those are fine. Probably we typically tend to see customers use private addresses, routable private addresses, for the interfaces on MCR. But you certainly can use link local if you want to. It does support public IPs if you want to. There's definitely use cases where customers use MCR for public routing, and it also supports IPv6. And last one here, BFD is supported as well. I would suggest that probably BGP is going to be a benefit in the metro. So if you've got links within a metro, so from one MCR to another within the same city, or from the MCR to a cloud or a data center within the same city, you're almost better off with BFD enabled almost always. If you start to have very long links, especially if you start to have high latency links, if you've got a link from sort of Sydney to London sort of thing where you're looking at triple digits of latency, BFD can sometimes be more of a hindrance because it can occasionally essentially trigger false positives and flaps unnecessarily. So generally, I would suggest enable BFD within a metro. Often disable it if you're going outside of a metro unless you're quite close by. Okay. And some new stuff recently added to MCR. Essentially, we now do larger sizes, so we now do up to 100 gig per second. We do have the ability to do layer 3 and 4 stateless ACLs directly on MCR. That's a pretty recent addition. IPsec tunnels are available as well, now up to 30 tunnels. Those tunnels are created essentially underneath the VXC interfaces. So when you create a VXC, whether it's to a data center or to the cloud, and more commonly with IPsec to the internet, on that interface, you can create these tunnels underneath that interface, and they have their own IP configuration, their own BGP configuration for point-to-point tunnels. We also support alerts for BGP status directly from the portal, so you can configure those. You can receive email alerts. However, we actually are also in the process of rolling out webhooks. I don't think BGP alerts are covered by webhooks just yet, but that should be available very, very soon. So we can also have that available to basically call a monitoring system directly, or some other automated workflow or something like that that you might have in place based on those state changes. So we did have a question come in just before we jump to the demo. Shared or dedicated bandwidth. So it's the whole thing is built on Megaport's private network. So we essentially have it's like none of this is tunneled over the internet unless you explicitly do it. So you can deliver an internet connection to an MCR, and in that case, obviously, it's the internet. So there's no guarantees about bandwidth after it leaves Megaport's network. But all the VXCs, cloud connectivity, connectivity to data centers and things like that, it's all over Megaport's private network. So there are some guarantees around loss and latency and things like that. On our website, we have a matrix that shows some details about the packet delivery guarantees, and that's in our service agreements as well. So it is some of the resources are shared in that it's one network, but we do have some guarantees around latency and loss and things like that in the sense that it is a private network, and the reason customers will want to use that is because they need some certain guarantees. Okay, so this is the portal that you get access to. So this is sort of where you would do that self-service process where you'd create and modify resources as required. I've got two MCRs here that I deployed earlier with a VXC between them. So this is essentially that middle section of the diagram where there's the two MCRs and the link between them. And then these MCRs would be used to connect out to all the cloud providers or data centers or whatever it happened to be. We've got some other videos that kind of go through the actual deployment process in a little more detail, but this one, I guess, is a bit more about some of the routing specifics and some of the suggestions around the layer 3 architecture that we see customers deploy. Bearing in mind, there's not actually any rules. You can configure this however you like. So if we jump into the VXC configuration here, we can see here that because this VXC goes from one MCR to another, we can see the IP and BGP configuration for both ends in the portal. So we can see the IP for this end there, and we can see the BGP configuration down here. So, and this one, like I mentioned before, both MCRs use the same ASN because they're both in the same metro. And often that's what we see is customers will have two MCRs per city, so per metro. Those two MCRs in the same ASN, different metros, different cities in using a different ASN, which again is optional, but that tends to result in the type of behavior most customers are after and behave the way people expect. So if we jump into this BGP configuration here, we can have a look at some of the advanced options. So firstly, to note here that the MCR ASN can be overwritten on a per session basis. That sometimes comes up. Sometimes you need to be able to modify the local ASN that's used in a particular BGP session. AS prepend is also configured in here. It's pretty straightforward. You basically just put a number in the box of how many times you want this local MCR's ASN to be prepended on routes that get advertised. The larger the number, the lower the priority of the route, and that tends to be the most common way that customers influence route priority. MED is available down here as well. You can set MED both inbound and outbound, so that can be useful as well to influence priority inbound for routes coming into the MCR. Obviously, outbound is available as well if you do want to use that. BFD is down the bottom here. Very, very simple, on or off, basically. Like I said, would recommend it for links within a metro, maybe not for long distance, international, intercontinental type links. And then filtering. This section basically lets you apply filters. So you can choose whether you advertise by default or don't advertise by default. So if you advertise by default, then you're basically saying that you want to advertise everything, and then you'll add specific rules to exclude things. By exception means you don't advertise anything, and you'll add specific rules to allow what you want to be advertised. So in this list here, you'll essentially see all of the other BGP sessions on the MCR, and you can sort of say you want this session to advertise to this session, but not others, right? You can choose which peers routes get advertised to which other peers. And then down the bottom here in this section is where you can configure prefix lists for the more granular route filtering. So essentially what you would do is create the prefix list where you specify the prefixes, the size of the list, the range essentially, whether to match or not match. And then you can use those to essentially say that you want to only advertise the routes that match the prefix list, or whether you want to advertise everything except the list, right? So that's the difference between a permit and deny. And you can do that both on import and on export. So on import, as in routes that are coming into the MCR, and on export, as in routes that are being advertised out of the MCR. And this is within the peer. So this applies to this one specific peer, and you can configure these separately for all the different peers. One last thing very quickly to show you where these are configured. If you click on the MCR itself, this is where the prefix filter lists are actually created. So they're created at the top level, and then they can be referenced down the bottom multiple times. So they can be reused across multiple peers because they're created at the top level here under prefix filter lists. Okay. Pretty brief run through there. We did try to cover quite a lot in this session, but that's pretty much it for today. If you do have any questions, feel free to reach out. Either reach out to your account manager or leave a comment on LinkedIn, however you want to go about it. We're always happy to answer questions or jump on a call. Otherwise, if you happen to be watching this later on YouTube, feel free to leave a comment. We'll try and keep an eye on those and use that to drive some of the future sessions. But otherwise, that's it. I will see you next time.